let's look into maximum and minimum values. So I'll start off by linear equations and then we'll gradually progress. So for linear equations, suppose it is given that a plus b is equals to 20, okay, and you have been asked to calculate the maximum value of the product a into b. Now I'll give you the idea. The idea is that the maximum value of the product is achieved only when the sum is constant, when a is equals to b. Now this, as a property, you should remember. You can try out different values for a and b and check. Ultimately you will reach the maximum value is only attained when a is equals to b. Now this is only viable when the sum of this thing is constant. Okay, for this a plus b is equals to 20, maximum a into b or a dot b, whatever, is going to be 100. You can check with numbers, but I'm leaving it to you. What if instead of 20 it was given as a plus b is equals to 21? Think about it. So here, before you jump into the thinking that it can be 11 into 10 or something of that sort, the first thing that should strike you is that it can be 10.5 into 10.5. Okay, two equal numbers wherein a and b are equal. If could be if the integers are allowed. Suppose if integers are not allowed, then we'll have to remedy that with some logic. But then if integers are not, if it could be if integers are allowed. So for example, 10.5 is not an integer. Okay, so strictly speaking, the value 10.5 into 10.5 will be the max value of the product a into b, which you can also use the calculator or you can do your speed maths to arrive at, which is going to be 110.25. okay, this is going to be the maximum product for when both the numbers or the variables a plus b is equals to 21. okay, remember, this is only when the condition is not asking you strictly for an integer. If it asks you strictly for an integer, then 10.5 and 10.5 will not work, and then probably we'll have to remedy it with logic. Just now I said, then probably it can be 11 into 10 or something of that sort. Okay, but the thing that we have to understand, if strictly they ask you for integers, then the thing that you need to understand is that the individual values a and b will be picked such that they have to be as close to each other as possible. The difference ideally should be 1. It can be 2, if nothing else works, but then again it is more like a logic ka question than a quant ka question. Okay, now let's look into another scenario in which we have 3 variables. Say a plus b plus c, that is equals to 21. Now tell me what is find ABC, the product ABC max. Now I am pretty sure that you have already arrived, that is 7 into 7 into 7, 7 cube, that is 343. You should remember that value. But even if you don't remember this value 343, I'm still happy with 7 cube or 777. The same idea, if a plus b plus c is equals to, let's say, 22. In that case, we will be taking the number a, b and c as close as each other, because obviously 22 is not splittable or divisible by 3. So the numbers a, b and c could be 7, 7 and 8. Somebody can say at this point that why is it that we are not taking 8, 8 and 6? For the simple reason that 8, 8 and 6 will not be as close to each other as 7 and 8. The difference will be 2, and here the difference is less. Okay, before I proceed from here, I must tell you one more important thing. For a plus b plus c is equals to 21, it is very much important that a, b and c should all belongs to natural numbers. In other words, a, b and c has to be greater than 0. If you allow negative numbers or negative integers also, you can typically form for A plus B plus C is equals to 21. I can form it like minus 100 plus 221. So this will give me 21, but the product will be a humongously huge number. So the max value will be that of 221,000. Okay. So it is very important that the question should specify that A, B and C should be natural numbers. If they are not natural numbers, then the prediction will be very difficult. So typically that is the reason why you will keep on saying that A, B and C belongs to natural number or positive integers. It should be there. Let's take a question. Let's try and understand. So the same pattern, A plus B plus C is 21 given, and you have to find the max value of the product of A minus 2, B plus 3 and C minus 4. I'll give you like some time. If there's a condition also, if A is greater than 2, B is greater than minus 3 and C is greater than 4. Now before you start doing algebra left, right and center, one thing that I want you to understand is that this thing is given for a reason. Please do not ignore this thing and proceed by doing all sort of algebra with these numbers. Have a you are given 2 eyes, so keep one eye to this thing. See, one thing is for a fact that A plus B plus C is equals to 21. So let's write that thing. A plus B plus C is equals to 21. Now A minus 2 is as good as subtracting 2 from 21. B plus 3 is as good as adding 3 to this number. So I'll add that number. And C minus 4 is as good as adding a minus 4 to this number. Okay. Now 21 minus 2 is 19. Hold on, this is 6 minus 3 is 21 minus 3. 21 minus 3 is 18. Okay. 21 minus 3 is 18. Let me just check once. Yeah. So now the three numbers are as good as, you can split them as 6, 6 and 6. So the max value of these numbers will be 216. Okay. You can think of the numbers as, why not, sir, let's do all of them equals to, let's say 7 and 7 and 7, and then A minus 2 is equals to 7, so A will be 9, and then B will be, let's say 10, and C will be 7 plus 4, that is 12. But remember, in this case, A, B and C are not equal. And if A, B and C are not equal, how will you get the max value? So even if you say that, I'll split them as 7, 7 and 7 and I'll get a 343, but that 343 is not true because all the numbers are a little different. They're not exactly 7, 7 and 7. So this was a sort of a question which could have been categorized as a little difficult, but then, yeah. Okay. Now let's look into a very interesting question, a difficult question. Okay. And the question says that for the same, thing, A plus B plus C is equals to 21. And you have to tell me, find the max value of A into B square into C raised to the power 4. Now there are many ways to do this thing. Okay, there is a very elaborate way through the AMGM inequality. But for that AMGM inequality, always remember that the question has to specifically mention that A, B and C has to be greater than 0. Okay, this has to be there. Otherwise the same idea will happen, right? The one that we just mentioned, minus 100 plus 221, the same thing will happen. So they have to mention this thing. So yeah, AMGM inequality is there, but then can we solve it through logic? Let's try to do that. Okay. Now see, a, b and c can be split like a plus b by 2 plus b by 2 plus c by 4 plus c by 4 plus c by 4 plus c by 4. Why is it that I'm splitting it, the a, b and c, into numbers like this? Because see, in the product here I have a b square. So if I split b into halves, I will get a b square, but I will also get an extra 1 by 2 from both the sides. But that's fine. Remember this, that this entire expression is equals to 21 that is given to us. Okay. Now at this point, tell me how many terms are there. So 1, 2, 3, 4, 5, 6, 7 terms are there. So in other words, a will be 3, b by 2 will be 3. This means that b will be 6 and c by 4 will be 3. That this means c is equals to 12. So the max value of this expression can be calculated as, how will we calculate the max value? We will calculate the max value. At this point, the max value could be calculated as, for a we will simply write it as 3, for b we will write it 6 squared, and for c we will write it 12 raised to the power 4. And yes, this is the maximum value of the expression a into b square into c raised to the power 4. Okay. Now for those of you who is not very much convinced with this and you want to check this thing with the AMGM inequality, remember that we did this with the logic. You can use AMGM inequality also. Let's do the AMGM inequality. So I'll write the numbers, the same thing. Given a plus b plus c is 21, and we need to find the a into b square into c4. We need to find the max value of this. But then we have to split the terms a, b and c into the same expression, which is a plus b by 2 plus b by 2 plus c by 4 plus c by 4 plus c by 4 plus c by 4. Now remember, arithmetic mean is always greater than or equals, at the max it can be equal to geometric mean, but arithmetic mean will always be greater than geometric mean. There are 7 terms. So the arithmetic mean will be sum of all this divided by 7 greater than equals to the 7th root of this number. But remember, this number is, we are not looking at this number and this number. Now we have split the a plus b plus c as a plus b by 2 plus, so that we get to this value. Okay. So the numerator will be a into b square into c to the power 4, but the denominator will have 4 raised to the power 5. So 1, 2, 3, 4 and another 4 with these two. So 4 raised to the power 5. Okay. So this can be written as, remember this is 21 raised to the power 7 by 7 raised to the power 7. Or at the same time, I could have easily written it as 3 raised to the power 7. Okay. Because 21 by 7 is 3. I am transposing the square or the 7th root to the LHS, making 3 raised to the power 7. This is equals to, or I should also transpose the 4 raised to the power 5. There I get, this is greater than equals to a into b square c4. Now obviously this thing is not very much similar to what we have found in the previous case. Let's recall what we calculated in the last method. The thing that we calculated was 3 raised to the power 7. Hold on. The one which we recall is 3 into 6 square into 12 raised to the power 4. Okay. Now 6 is 3 into 2, the whole square, and this is 3 into 2 square, the power 4. So if you look at this, this is 3 into 2 square into 3 raised to the power 4 into 4 2s are 8, 2 raised to the power 8. Okay, this is 4 and 2 6, 3 raised to the power, hold on, this is going to be a square. So 4 2 6 1 7, 3 raised to the power 7 into 2 raised to the power 10. This is what we received in the last case. And for this part, let us do the primes. Let us write them in the steps of primes. We will get 2 square raised to the power 5 into 3 raised to the power 7, which is as good as 2 raised to the power 10 into 3 raised to the power 7. So either ways, if you use AMGM inequality or you use the logic, you'll arrive at the same answer. Now let's do, let me tell you the shortcut for this. There is a shortcut because these are very, they're not very difficult. So the shortcut says, remember that we were given a plus b plus c as 21. So a plus b plus c as 21 was given. And we had to find out a, b square and c to the 4. Now at this point, tell me the sum of the powers. That is equals to 4 2 6 plus 1 7. Divide this 21 by 7. That is going to be 3. Okay. Divide the sum of terms by the sum of powers. And we can directly write. So this is the second step. First step is obviously to understand what is given. We can directly now write a is equals to 3. B will be, please remember, 2 into 3. C will be 4 into 3. So A, B and C you have got. This is 3, this is 6 and this is 3 4s are 12. We were supposed to find out the product of the max value of this, and the product of the max value will be 3 into 6 ka square, because B ka square, into 12 ka raised to the power 4, which is that. So this is a typical shortcut that you can also use. This works with simple numbers. All right, thank you.